So, good afternoon, student. So, in this lecture, we'll see a PN junction diode, its characteristics and current equation. So, I will select a pen. Yeah, yes, I will check. Okay, I will check the color. The screen color I will choose as black color. Okay. So, in this lecture, we will see the PN junction diode, its characteristics and current equation. Okay, this is lecture number I think 8 to 9 lecture. This is lecture number 9. So those who are not subscribed my channel, please go through the subscription. Please subscribe the channel. If you are subscribed to the channel, then you will be getting the latest updated of each and every video which I have uploaded on my YouTube channel, like lecture number 4, 5, every lecture. If you are browsing through my playlist, so entire lecture series of EDC you are getting in this one. Okay, EDC you are getting in this one, and in which I have explained everything. Okay, everything which concept I have explained in detail. If you are not still watch the videos, please go through videos of from first lecture in which we have discussed syllabus. So please subscribe and press on bell icon also. So this we have seen that is nothing but semiconductor material, and that is silicon, germanium, GaAs. Okay, we have seen in this previous lectures this thing. So directly I will start with a PN junction. Yeah. So okay, PN junction. So what exactly it mean by PN junction? So we know that P type material. Okay, that is we are adding what? Boron, indium, and gallium. Okay, gallium. If you are adding these three in the pure semiconductor like silicon, germanium, or GaAs, anything that are the pure form, we can't use that in practical use. Okay, so we are adding some kind of impurities. Impurity means we are adding something in the pure form, that is nothing but the boron, indium, and gallium. If you are adding that thing, so whatever the resultant is nothing but my p type metal. Okay, p type metal. Yeah, and if I'm adding arsenic, okay, antimony, and phosphorus to this pure silicon, germanium, or the resultant material will be what it is exactly. It is nothing but the n type material. So we are having that material. So in that material, what will happen? Due to some impurity mismatching, some kind of minority charge carriers are also there. That is nothing but in the p type. In the p type, we know that holes are there. Okay, holes, positive charge particle, we can say that are there. And in the n type, electrons are there, because one valence electron will be free electron we are getting. But simultaneously, what will happen in case of p-type material? Some electron will form. Some electron will form due to some mismatching of the component. Okay, semiconductor material. So what will happen? The minority. Suppose the electron in the p-type, suppose holes are 1000, so 10 electron will be formed. And in the n-type, what will happen? In the n-type, what will happen? If electrons are 1000, so 10 number of electron holes will be present over there. So if you are joining these two, then what will happen? Here electrons are there, they will get attracted. Here whatever the holes are there, they are get attracted, and they are forming one junction over here. Whatever the boundary where they are joining, that is called a junction. Okay, junction. And whatever the layer formed by these two is called as what? Depletion region. Okay, what is called as depletion region. So what exactly mean by depletion region? The whatever the minority charge carrier of p type and whatever the minority charge carrier of n type, they are get attracted, and they will form a junction. They are forming the junction. So whatever the resultant layer is called as depletion layer. Okay, it is clear to you? So number of minority charge carriers are more. Number of minority charge carriers are more. That means that this junction, this depletion layer will increasing. This depletion layer will increasing. Keep in mind, if we are having 10, so this is less. If you are having 100 minority charge carrier, so junction will be, that depletion layer will be increasing. Okay, depletion layer will be increasing. So diode is this material. If you are adding some kind of lead over here, so this is the diode. This is diode. So potential across this is nothing but my VD, and current flowing through this is nothing but my IT. Okay, current flowing through positive and negative. So anode, we are saying that the P type material, that is nothing anode, and N type material, we are saying that cathode. Okay, cathode itself. So if diode current diode is just like a one-way switch. One-way switch means we know that this is a one-way road. Okay, so traffic is allowed in this direction only, not in direction, not in this direction. Okay, so one way. So if you current flow in this direction only, if you are flowing from this direction, it won't flow. It will appear as open switch. It is like as a open switch. Okay, so diode operating conditions are there. So there are three operating conditions of diode, that is nothing but the no bias, forward bias, and reverse bias. So what exactly mean by no bias, reverse bias, and forward bias? So if the diode, this is the diode, in this one we are clearly able to see this is depletion region. If you are not connecting anything into it, just a minute, just a minute. Okay, fine. So what will happen? If you are not connecting any supply, any potential across these two terminals, that is nothing but the anode and cathode. If you are connecting nothing at all, so whatever the condition is called as no bias itself. Okay, and if you are connecting, if you are taking a battery, we know that battery is having positive terminal and negative terminal. Positive terminal and negative terminal. If you are connecting my N type, that is the negatively charged, that electrons are there, to the P type, sorry, positive terminal of battery, and the negative terminal to the P type of the battery, then what will happen? We know that opposite charge carriers are attract to each other. Opposite charge carriers are attract to each other. So the positively charged particle, that is the holes, are that are get attracted by the negative terminal of the battery, and the electron will get attracted toward the positive terminal of the battery. So what will happen? This depletion region will get increasing, because electron holes will go in this direction and electron will go in this direction, so whatever the depletion region over there, this will get increasing. Okay, this will get increasing because the minority charge carrier will, what you can say, they are forming the junction. Yeah, so in the forward bias condition, what will happen? We are connecting the P, that is the positive terminal of the battery, to the P type material, and N type material to the negative terminal of the battery. That is how to remember this: P type to the positive, N type to the negative. Then what will happen? This is the negative terminal over there, so electron will get attracted. Sorry, holes will get attracted in this region, this side, and the electron will get attracted this side. Okay. Here, if you are saying, if I am applying positive, so it will get a repelled. Okay, it will get again repelled. So what will happen? Just a minute, repel, and they will go to this, so depletion region will break down. Okay, disappears. So no bias condition. So no bias condition is what? We are not applying any kind of voltage over here. We are not applying any kind of voltage over here, that is the VD. So the voltage drop across is zero, so current is flowing through this is zero. This is nothing but just take a diode and keep as it is, don't give any voltage itself. So voltage is zero, current is zero, only modest depletion region is this. That is nothing but the whatever the region previously we are having, that is as it is. Okay, there is a no bias condition. So the word bias is nothing but to give external power supply. External power supply, if you are giving, means just we are lighting the torch. Okay, that is nothing but we are connecting battery to the LED. Then torch will, what you can say, what will happen with the torch? It will glow. So in the reverse bias condition, what will happen? We are connecting negative terminal to the P type and positive terminal to the N type. Okay, so in this case, what will happen? So this, here we know that there are holes are there, but minority charge carriers are there, that is nothing but the electron. So electron will get attracted to this side because we are having positive potential over here, so electron will get attracted this side, then holes will get attracted this side, and they are forming the junction. So this junction is more than the whatever the we are having in the previous case. Here So this width will increasing. But if you are increasing the voltage in a voltage and voltage increasing, means if you are giving -1 volt, -2, -3, -4, -5, -6, -7 at certain voltage near about 40 to 50 volt. Okay, 40 to 50 volt, what will happen? This, whatever the current conduction is, that is nothing but the due to the magnetic charge carrier. Okay, now current, we know that current, whatever the magnitude of current is nothing but the opposite direction of electrons. So what will happen? Electrons are flowing in the direction now. In this direction, electrons are flowing. So current cause to flow is due to this direction. In this direction, from positive to the negative, like this one, current cause to flow. So this current is called as IS. That is nothing but the reverse saturation current. So keep in mind this reverse. If you are applying 1, 2, 3, 4 voltage, current will not go to flow. But if you are increasing the voltage near about 40, 50 volt, -1, so that is nothing but the breakdown will happen and the current goes to flow. Okay, in the forward bias condition, what we are doing, we are connecting p type, the positive terminal, that is nothing but the anode, to the p type material, and nothing but the positive negative terminal to the n type material. Okay, we are connecting like this one. So positive terminal to the p type and n type to the negative terminal. Then what will happen? So the depletion region, what will happen with the depletion region? Here we are having what? Electrons. We are having electrons, and here is the positive terminal. What you can say, here is the positive supply. So the electron will get, what you can say, attracted in this side, attracted at this side. But this is nothing but negatively charged. Sorry, this is nothing but what? Minority charge carriers, and here holes are there. They are get attracted this side. So what will happen? The current goes to flow in this direction. Okay, in this direction, because whatever the electrons are there, here negative terminal is there, and here electrons are there. So electron will go like this one. Okay, go like this one. Here electron will go like this one. The electron, whatever the electrons are there, they are getting shifted toward this terminal. Okay, this region, and whatever the holes are there, they are getting shifted to this region. So overall current is nothing but I majority, that is nothing but the whatever the current flow to the majority charge carrier minus whatever the uh, current flows to the uh, saturation current, that is nothing but reverse saturation current. Reverse, that is nothing but the minority charge carrier. Okay, so what will happen in this case? What is happening over here? So in this case, I have drawn the characteristics of a diode. A diode. So here I have shown this dotted line, that is nothing but for germanium, 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 and here it is for silicon, silica. So what will happen if you are increasing the voltage across this in the forward bias case only? Reverse bias, here the reverse bias, negative voltage I am applying. So here what will happen? If you are increasing the voltage 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.4 for germanium, I am telling, 0 0.4, at 0.37 voltage, what will happen? The junction means the whatever the depletion region is there, here depletion region is there, still depletion region is there, 1, 2 and zero point 0.3. At 0.35 voltage, what will happen? This junction will break and the current goes to flow. Current goes to flow, like whatever the current is nothing but 20 30 milliampere itself. As silicon is there, so at 0.67 volt, at 0.67 volt, the current goes to flow. The whatever this point that current goes to flow is called as breakdown point or knee point. You can say that. What you can say called as knee point. Okay, keep in mind what I am doing. Knee point. Are you getting what I am trying to say? If you are getting, then give me thumbs up in the chat box. I am waiting for your comment. Okay, so we will go. So in the reverse case, we are applying the voltage reverse minus order. The current is not going to flow. Current is not going to flow. So whatever this is in the microampere, keep in mind this is very small current cost to flow. Okay, and at certain voltages, the breakdown will happen and current cost to flow. Current cost to flow. Means what? Suppose someone is, what you can say, if you are holding the door. Okay, if you are holding door, and from opposite side, suppose one person is there, he is forcing you. You are resisting. If two persons are there, still you are resisting. If three persons are, still you are resisting. But four, five, six persons are there, then what will happen? You are breakdown. Then you are saying, okay, let current cause to flow. So like this one will happen with this diode. 10, 20, 30, 40, and at the more than 40, 50 volt, what will happen? The current goes to flow. The diode potential equation is given by Is in bracket e raised to Vd neta nVt minus 1. So what exactly mean by? So Vt is there. Vt is nothing but Kt by Q. Okay, Kt by, this is nothing but the thermal voltage, and Is is nothing but the reverse saturation current, the current caused by reverse. If you are applying the reverse, that is nothing but microampere, and Vd is nothing but the voltage across the diode. Okay, okay, here I have shown everything. So Vt is nothing but the thermal voltage, then Is is nothing but the reverse saturation current, and Vd is nothing but the voltage applied, forward voltage applied across the diode. N is the ideality factor. So normally its range is one between 1 and 2. Normally we are taking as one value. Okay, one value over here. So the graph is exponentially increasing. So we are taking as e raised to Vd minus nVt. We are taking value of n is equal to 1 minus 1. K is Boltzmann constant. We know that its value is how much? 1.38 into 10 raised to minus 3. And T is temperature in kelvins, 273 plus whatever the temperature, room temperature itself, 27 plus means 300 Kelvin. And Q is nothing but the charge of the electron, that is nothing but the 1.6 into 10 raised to minus 19. So electrons are there, we have to mention minus 1. Okay, holes are there, that is nothing but the plus 1. So we will going to stop over here. So I think you like the session. So thank you very much for attending this lecture. In this lecture we have covered n type, p type and everything. Okay, if you are having doubt, so please go to the playlist and watch the videos from first. Okay, so thank you very much for attending the lecture.